Today on AI Paper Podcast, we are diving straight into evaluating AGENTS.md, our repository-level context files helpful for coding agents, by Thabo Glogan, Niels Mundler, and the team from ETH Zurich and LogicStar.ai.
The premise here is something everyone in the industry, including Anthropic and OpenAI, strongly recommends, which is adding context files like AGENTS.md or Claude.md to your repositories to help coding agents understand the code base.
But the shocking finding we are looking at today is that following this advice might actually be a massive mistake. Auto-generated context files, the ones created by LLMs, actually reduce task success rates by 3% on average.
And they simultaneously increased inference costs by over 20%.
Even carefully developer-written context files only improve performance by a marginal 4%, while still driving up those exact same inference costs.
So the bottom line is, if you are running init commands to auto-generate context files for your agents, you are highly likely paying more for worse results.
Okay, let's unpack this, because adding these files has basically become standard engineering practice over the last year.
It really has. I mean, over 60,000 public GitHub repos now have them.
Which is a huge adoption curve.
Right. And the theory behind it makes total sense. As agents work on novel or, niche code bases, they lack the training data context.
So the files are supposed to be like a map.
Exactly. A map or a highly specific readme just for the bot. It lists tools, style guides, build commands, all the stuff a junior dev would need on day one.
And the big frameworks, OpenAI, Anthropic, Qwen, they all have these built-in commands to generate these automatically. It feels like this totally free win. You just type a command and your repo is optimized.
Right. But despite all that hype, nobody had actually vigorously tested if they work at scale. And that is exactly the gap this paper fills.
So how did they test this? Because usually when we look at these coding agent papers, they just use SWE-bench and move on.
Yeah, here is where it gets interesting. They couldn't just use SWE-bench Lite.
Why not?
Because those repositories, things like Django or scikit-learn, they're just too popular.
Ah, right. The models have already memorized them during pre-training.
Exactly. Plus, those historical SWE-bench snapshots absolutely do not have developer-written context files in them. The concept didn't even exist back then.
So they had to build something new.
They did. They built AGENTBENCH.
Okay, break down AGENTBENCH for us. What makes it a better test for this?
They pulled 138 instances from 12 real-world niche repositories. We're talking about modern repos like TinyGrad, SmallAgents, Ragus, FastMCP.
So very specific, highly technical frameworks.
Right. And crucially, these repos already had developer-committed context files. The actual maintainers had written them.
That's a huge detail. They aren't just making up synthetic files to test.
Exactly. So they could compare performance across 3 distinct settings. First, the none setting, where there was no context file at all.
Just flying blind.
Right. Then the LLM setting, which is the auto-generated context that everyone currently recommends. And finally, the human setting, the actual developer-written file.
And they tested this against the heavy hitters, right? Like Claude Code with Sonnet 4.5.
Yep, Claude Code. Codex using GPT 5.2 and GPT 5.1 mini, and Qwen code using Qwen 330B.
So state-of-the-art across the board.
Absolutely.
Okay, let's dig into that performance drop you mentioned in the intro. Why on earth is the LLM setting performing worse than having no file at all?
It's pretty wild. On both SWE-bench Lite and their new AGENTBENCH, the LLM-generated files caused a drop in success rates in 5 out of the 8 settings they tested.
And the cost goes up across the board.
Universally, a 20% to 23% increase in inference costs.
Is that just because the prompt is longer?
That's part of it, but the big driver is that the agents took significantly more steps to solve problems when the file was present. We're talking about an extra 3.92 steps on average.
So we're basically just confusing the model. We give it a map and it gets lost.
Precisely. And remember, even the developer-written files, the human setting, they only boosted success by 4% on AGENTBENCH.
Which is barely anything.
Right. But you still incur that massive cost penalty for the extra steps. It's a very expensive marginal gain.
So what are the agents actually doing during all those extra steps? Are they just, ignoring the files?
That's the logical question, right? Are they just hallucinating past the instructions? But the answer is definitively no. They are definitely reading them.
How do we know?
The tool use traces prove it. When a tool like, say, Uve, or a custom repo tool is mentioned in the context file, the usage of that tool just skyrockets.
Like how much?
For example, Uve usage went from less than 0.01 times per instance to 1.6 times per instance.
Wow, okay, so they are highly compliant.
Very compliant. But here is the problem. Agents with context files engage in much broader exploration. They run grep more often, they read more files, and crucially, they run way more tests.
Wait, isn't running tests a good thing? I want my agent to test its code.
In a vacuum, yes. But it looks like analysis paralysis. The context file encourages them to check absolutely everything, which leads to all these rabbit holes.
Ah, so they are overthinking the problem rather than just fixing the obvious bug.
Exactly. They get distracted by the sheer volume of instructions.
It's like when you give someone driving directions that are way too detailed, and they get so focused on looking out for a specific gas station that they miss their actual turn.
That is a perfect analogy. The file creates cognitive overhead.
So is there literally ever a scenario where these files are a good idea, or should everyone listening just go delete their agents.md right now?
Well, there is one scenario, and it's a key nuance in the paper. The researchers did a scorched earth ablation study.
Scorched earth? I like the sound of that. What did they do?
They went in and deleted all the other documentation from the repo. No Redenbauer files, no docs folder, nothing.
Just raw code?
Just raw code. And in that complete documentation vacuum, the LLM-generated context files actually did outperform the developer files and the none setting.
Oh, that's fascinating. So the context files are just redundant.
Exactly. That is the key insight here. If a repo has good docs, AGENTS.md is just noise. It's only useful if the repo is completely and utterly undocumented.
Which, to be fair, is a lot of internal corporate code bases.
Sure, if your code base is a chaotic mess with zero comments, maybe an auto-generated map helps. But for any well-maintained project, it's actively harmful redundancy.
I have to ask, though, maybe the auto-generated files they tested were just poorly written? Did they try using better models to write the context files?
They did. They used GPT 5.2 to write the context files, thinking a smarter model would write a better map.
Makes sense. And did it?
Surprisingly, no. It actually degraded performance on AGENTBENCH compared to files written by weaker models.
Wait, the smarter model made things worse. How does that work?
Because a smarter model is more thorough. It writes a longer, denser file that includes every tiny detail about the repo.
Which just gives the agent more rabbit holes to get lost in.
Exactly. They measured this using a metric called time to first relevant file interaction. Basically, does the file help the agent find the broken code faster?
Let me guess. It didn't.
It did not. The context files did not help agents find the right file any faster. They are fundamentally ineffective maps.
Man, that is damning. So what does this all mean for the engineers listening to this deep dive right now? What is the actual takeaway?
The researchers have a few very clear recommendations. Number one, stop auto-generating these files.
Just abandon the init commands.
Do not use them and expect magic. It's almost certainly hurting your pipeline. Number two, if you insist on writing one manually, keep it incredibly minimal.
Like how minimal?
Don't dump the whole repo structure in there. Only include specific, non-obvious tooling instructions, like use U for dependencies in this specific folder.
Keep it scoped.
Highly scoped. And number three, focus your energy on standard documentation. Good docs written for humans are actually better for the agents than a specialized agent file.
It's kind of ironic, isn't it? We keep trying to invent these special languages or formats to talk to the AI, but it turns out humans are still better at writing these files. And even then, the ROI is terrible compared to just writing a good old-fashioned read-m.
It really is. It shows we might be overthinking how we interact with these models.
Well, as we wrap up this deep dive, I know you had a final thought on this, a sort of bigger picture reason for why this is happening.
Yeah, this is something to maybe mull over. I suspect context files fail here because we are trying to patch a knowledge gap in Python.
What do you mean by that?
Python is a language these models already know intimately. They have seen millions of Python repos. When you give them an agents.md for a Python project, you are basically mansplaining the language to an expert.
Right. They already know how the imports work and where the tests usually live.
Exactly. But the real value of context files, the place where they might actually be a superpower, could be in obscure languages or highly proprietary legacy systems.
Where the model truly has zero prior knowledge from its training data.
Right. If you are asking an agent to fix a bug in a 30-year-old internal banking language, then yes, an agents.md file detailing exactly how that system compiles is probably essential.
Because it can't rely on its pre-training instincts. That makes total sense. We're just applying the tool to the wrong domain right now.
I think that's highly likely.
That is a fascinating thought to leave on. Thank you to everyone for joining us on this deep dive. As always, you can find the link to the full paper in the show notes. Go read it, maybe delete a few auto-generated files from your repos, and we will catch you next time on AI Paper Podcasts.